Look at this question here. This is a lamb lad, So I was talking. So you see, like this question here. So a crate weighing 1,000 Newton, like that. So I'm gonna be explaining this question, then I'll give you other questions so you can relate with that. Yeah, this is find the tension in this particular question, like I showed you earlier, the which is 1,000 meters. So the tension in the rope. So I said the tension in the rope is simply the force acting in that rope. So when you drag a particular jar, a jerry can, a mop, or a bird, or a car. So when you put a rope attached to a door, or a car, or a mob, or wherever, or a pan, wherever, like that, the tension in that rope, the force in that rope you are using to drag that particular object is known as tension. So tension is simply the force acting in a rope or a string. So the tension here, we have to find the tension when the plane is being pulled up against the crate. So I told you that the reason why this block is stationary and the reason why this block will move is as a result of the coefficient of static friction. So when the tension is here, when the tension is moving up, when the rope is dragging the block up, the frictional force or the coefficient of static friction will be dragging it down, will be coming down, opposes motion. So frictional force opposes motion. And this is the coefficient of static friction. So we're going to resolve this component, finding the first question, the tension there. So for your first question, which is resolving components here. So in any of the questions so far, your first thing you resolve the component. Resolving components as usual. So resolving the components of this is my block. Then normal reaction, you call it normal reaction, you call it your R. And your R simply mean the same. So like I said earlier, now my normal reaction, if I will resolve the components for my y-axis and my weight is acting downward, negative. My positive x and my negative x. So looking at this junction here, this point P, it will be, if I resolve the components in y-axis, I will have my normal reaction N minus W cos 30. So I will explain that. The reason why I'm resolving my normal reaction to my W cos 30 is as a result of this degree. This degree, like I explained earlier, whenever it faces, come back here, you see, I brought this here from this point here to this point. Here it's sine 30. You understand that? Opposite, that is SOHCAHTOA, your SOHCAHTOA. So opposite, which is sine, and adjacent, which is cos. So here I will have my sine 30 and my cos 30. Now looking at it, bringing it here, that means here will be my W sine 30 and my W cos 30. So if I will resolve my normal to plane, that means I will have my N, which is my y-axis, and I will have this one, my other axis. That will be N minus W cos 30 degree. So I will solve for horizontal. So when I do that, I have my N as this, and I have my W as 1,000 Newton. So, and I did that, I have my normal reaction as 6 Newton, which is still the first question. So for my tension now, I resolve the components in x-axis. So my tension T is in the x-axis region, positive, and this is negative. So here, my tension T will be plus T minus W sine 30 plus T minus W sine 30. So you see, the frictional force does not have any value. Let me say it's not useless. Why? Because it's responsible for the reason why this block is stationary. You know, this rope is inch here. So the block is not moving downward, it's not sliding upward, it's just fixed. So this reaction is, this coefficient of frictional force is stationary there. So back to the question, when I resolve the components, I have my T, resolving horizontal, I will have my T at the positive side, minus, this is acting to this side, like this one here, W sine 30 is acting to this side. That is my x-axis. X-axis. So that will be T minus W sine 30 equals to 0. I resolve that. My sine 30 is 0.5, my W is 1,000. I have my T at 500. So the first question says, what is the tension when the crane is pulled up? Now when the plane is pulled up against the crane, the first question says, I say my tension will be 500. So this simply implies that The tension in the rope of the tension in the rope to push the plane is 500. The tension in the rope against the crate, against this particular block, is 500. So the next question says the tension in the rope. The tension in the rope when it's used to pull the crate up. So imagine this tension attached to this rope. I pull this rope up. I pull this rope up. That means this block will move, right? And my coefficient of static friction will be there. There is no frictional force here given. So therefore, my tension will still be 500, being the fact that the plane is smooth, it is frictionless. And the force acting on it is still the same thing. So my tension will still be the same thing. But at the end there is frictional force here. That means I will need to do my tension minus frictional force minus W sine 30. So for the third question, it says the tension in the rope, if the crate is allowed to slide down. So the tension in this rope, if this crate is allowed to slide down, imagine this block crate slides down. That means the coefficient of static friction, that is my frictional force, is greater than the tension. That is why it can slide down. So definitely my tension will still be equal to my frictional force. But here the frictional force is not given. So my tension still remains the same thing, because when it slides down, it will still be equivalent to the tension it's used to move up. I guess you enjoyed today's class. Do well to look forward to more. And I pray the Lord grant you understanding in the name of Jesus. Well done, guys. So any question, you look forward to the WhatsApp platform and you message me. Stay tuned. The Lord is our strength. This question, the coefficient of friction between a body and an inclined plane is 0.3. If the force needed to start the body moving up the plane is 3 times. So, very cool. Alright. So I want to say, see, now back to that question that view now. I said the 3 multiplied the 3 times. Look at this question. This is the diagram. Now look at this. If we're going to resolve this, it's different from this. How? This is the force going up, and this is your coefficient of kinetic friction. Here, you see the arrow going downward, and you have your normal reaction, you have your weight. Resolving this component is just like this. How? That means if I'm going to resolve this component horizontal, I will have my what? Force acting on the positive side. That means I will have my force up minus my coefficient of kinetic friction, that is my frictional force, minus my weight, that is for the W sine theta, equals to 0. So therefore I have my Fu equals to, so I will have my frictional force, that is my force, equals to my Un plus this. And that is how I got this when I resolved horizontal. So if I'm going to resolve vertical, what do you think my answer will be? Then I'm going to resolve vertical. So like I said, looking at this question here, these are 2 different questions, this and this. You can see here, the force is acting up while the frictional force is acting downward. And here, the force is acting downward while the frictional force is acting upward. So in this particular resolution, like I explained some few seconds ago, we're going to resolve this component for your vertical resolution. It simply is your N, which is your normal reaction, minus your W cos theta here. So your normal reaction minus your W cos theta. Why? I told you whenever this face is your what? Sin theta, and this one face your adjacent, your cos theta. So I'm resolving this my vertical, horizontal. So I have my vertical resolution as N minus W cos theta. And if you're going to do the horizontal resolution, I did that some few seconds ago, you can check that. And that is your F, your force up minus your frictional force minus your W cos minus your W sine theta rather. That is for that. So for this, we're gonna resolve this. You see, the force is acting downward and the frictional force is acting upward. So for here, resolving vertical, I will have my normal reaction minus W cos theta. Because this is my vertical, horizontal. So I said, if you're going to resolve the horizontal component, you can see here, this is acting negative, this is acting positive, and this is acting negative to this direction, negative. So you can see that will be resolving component horizontally. That will be my frictional force UN minus my force acting downward minus my W sine theta, and that way I will have this here. So my force acting downward will now give me, if I make a subject of formula here, this will come to this side. So if I have this here, you see, my frictional force, my force downward rather, if it comes to this side, that means I will have my UN minus W sine theta. So this question, this sample I gave you, is just to show different kind of plane crates we have in the directions like that. So I trust you can understand this, and I want you to understand it. So you have any question, you chat me up on the WhatsApp platform, and it's majorly for you guys. So you guys be good, and we look forward to the link. So you can do well to subscribe, so you can get the next message for the next class. All right, take care. Well done.